Okay, welcome back. As promised in the previous video to this one on the channel, we have a Wells Gardner K7400. I received the entire monitor. This came out of a 2-player NFL Blitz that obviously was running standard res, being this is a K7400. And the owner said, hey, this is working fine forever. And then one day I turned it on and nothing. So I got it home and I turned it on, and sure enough, it was just tick, 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 as I'm sure a lot of you are familiar with. And we're going to have to troubleshoot and figure out why it's ticking. Usually it's a bad HOT, but I haven't done any testing yet, so we'll have to find out. And this is a relatively low hour 7400. It does have a little bit of burn, but otherwise it's not too bad. It's a relatively low hour. The chassis itself is remarkably clean. It's amazing. And in sharp, stark, I kind of combined sharp and stark. In stark contrast to that, the flyback is filthy. So I don't understand how the flyback can be so totally filthy, but the main board is almost spotless. So it's very odd that that's going on here. And whew, I shouldn't have done that. Let's turn our fan on here. And let's see if we can clean up our flyback here on cam. That'll have to be good enough for now. Alright, well, okay, on with the show here. Let's first, as we always do, we'll disconnect our neck board, just so it's out of our way and we can work unencumbered by it. Okay, and again, if any of you are new to the channel, you can see Wells Gardner monitors, 25-inch 7400. So that's how you can identify this. There's also one on the main chassis itself, same thing. Well, this one actually says 74 on it. This is a different tag, but 74 is 7400 standard res. So, yeah, and let's get rid of our remote board, because we don't need that just yet. And we'll go over and look and... I dropped the remote board. Okay. We'll go over this and inspect it later, because it's not the cause of our problem. Let's get to the root cause of the problem first. Okay. So when you have a ticking 7400, 7500, U2000, U5000, it's usually a bad HOT. But not always. Sometimes it can be, the HOT can be bad, well, the HOT is bad because of various components, and the 5000, 2000 have different components than the 74, 75. So depending on which chassis you have, there's different courses of action to take. But the horizontal output transistor is here. And as I see this, I'm mystified already, because the C3686 is not what's normally in these. They're usually 3688. That's odd. It doesn't appear that anyone's changed it, because this was working. And then one day it wasn't, and then it came right out of the machine, and this came from a local friend, a local arcade enthusiast like myself, right out of his NFL Blitz, his 2-player NFL Blitz. It's different between the 4-player. The 2-player is 25-inch, and the 4-player is 27-inch. But so yeah, it came right out of his machine that was working, and then one day it didn't. So I don't think it's an issue, but that's an oddity. I don't recall these ever having the 3686. It's usually a 3688, at least from what I can remember. I could be wrong. I'm sure people in the comments will say something different if I'm wrong, but that's from my experience. Well, I guess first thing is we'll test the HOT, but somehow, some way, some reason they've got this on here, which let's just go ahead and get rid of that. We'll have to, I don't know what setup is in the machine, so I'll have to put this back on when I'm done here, unfortunately. But alright, so we'll get rid of that, and we might as well, I don't think anybody reflowed this. I'll do the reflow, of course, before I'm done, but I don't think anybody reflowed this. They just soldered those wires to these factory pads here that had almost no solder on them. So, alright, well, I don't see any bulging caps. I don't immediately see anything that's wrong. These are original caps, so we're going to have to cap it. And in preparation, I have a full cap kit here, so we'll throw that in there. But I don't see anything offhand immediately. So let's take our HOT and just test it and verify that it's good or bad. Okay, we're looking for a 0.5 voltage drop on between this pin and this one, and we do, and then of course this one. Well, look at that, HOT tests good. That kind of throws a monkey wrench into the situation, because most of the time a ticking chassis indicates a shorted HOT, but our HOT is not shorted. Now I can't say that it's good, all I can say is that it's not shorted. Very interesting. So that would indicate that there's not a faulty component. If there was a faulty component, it would have taken the HOT out. But since that's not shorted, let's test our power supply. We could simply have bad caps, because bad caps will cause the HOT circuit to not function and give you the tick, 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 tick. So sometimes it can be bad caps if the HOT is good in circuit. Well, if it's good in circuit, it'll be good out of circuit. But if the HOT reads good, it may just simply be bad caps. But let's check our power supply. You can usually verify that the power supply doesn't have bad components by testing R104. The main resistor here on the edge, this ceramic resistor, is supposed to be 10K ohm. Now it can read anywhere, on a functional chassis, it can read anywhere between 9K and 13K. I've seen them be down to 9.50 up to 13K. As long as it's within 9 to 13, usually you have a power supply that has a functioning circuit. You could still have a bad U101 switch mode power supply chip. That could still be faulty. However, if you have between 9 and 13K on the R104, generally speaking, most of your components in this section will be good, but you can still have a bad switch mode power supply chip even if this reads between 9 and 13. So let's just check it here. Yep, 9.70. So if you've got if any of these film capacitors or diodes or anything in this section is shorted or open or bad, this will usually read way out of tolerance. So at that point you would take the resistor out of circuit. If it reads correctly out of circuit, but in circuit it reads way out of tolerance, then you've got something wrong in the power supply section. But because this reads between 9 and 13, we can kind of rule that information rule it out and take that information as read. So I want to do the light bulb test to verify we don't have a power supply section, because U101 could be faulty, causing it to tick. So I want to rule out the power supply section. If we do the light bulb test and that passes and the HOT tests good, I want to move straight to a cap kit. Because, like I say, if there was any kind of component on this that was faulty, shorted, open, out of tolerance, what have you, the HOT would have got taken out. But because it reads, well, because it reads good, I can't verify. It could just be faulty, but once you put power to it, it fails. But with no power to it, it ticks okay. So I can't say with 100% certainty that it's good, but because it reads good, I'm tempted to say that it's probably okay. And if there was a faulty component, it would have taken it out. So I'm about 85.682% sure that we simply have a bad cap or bad caps causing this problem if we do our light bulb test and that passes. So I don't want to say we have a faulty. If C119 or C121, either one of these two caps here were bad, usually the HOT gets taken out. So as a matter of fact, let's go ahead and just check those real quick here. We're just checking to make sure that they're not shorted. I don't care what they read. We're just checking to make sure they're not shorted. So it should be, well, they're on that line. It should be this one and this one. And they are not shorted. Alright, well, I don't think it's a bad solder joint. Let's do our light bulb test and see what we get. So for the light bulb test on the 74-7500, L100 right here, this coil, this inductor, you take this leg of the inductor out of circuit and you clip on there to provide power to your light bulb. So let's go ahead and just desolder that. Because it's on this large plane here, I would just turn on the desoldering station, but it's so loud and annoying in the background that when I have to do that, I'll just use a braid to get that out of there. And then we lift the leg out. There you go. So if you look here, this leg of L100 is out of the circuit, just like that. And we'll clip a lead onto there, run it to our light bulb, and clip a lead on here, run it to our meter, verify we have good B+, verify that the light bulb lights up. If it does, then we'll move on to a cap kit and a reflow and see if that helps us out. Okay, let me grab a light bulb. Follow me, light bulb! Over here, Christmas tree! Okay, let's grab a red for our power, or for our meter I should say. We'll grab a green to touch our light bulb, and then we'll get, we need a negative for, let's zoom out here. Not that far, you dingus. Alright. Volts DC. So we have a red lead here for our meter. And we have a black lead here for our meter. We will touch this to our frame. And then our green wire we will touch to our light bulb, and then we'll touch our light bulb to the frame, and it should light up. Okay, so you don't need anything other than power, so we'll plug in power from the test bench. Make sure nothing's touching, make sure our leads are intact. Alright, so the purpose of L100 there is to provide the B+ from the regulated power supply to the rest of the chassis. By lifting that out of the circuit, you're taking the rest of the circuit, fly back everything out of the equation, and the only thing that's actually powered is the power supply section. So that's why you can run this without having to hook it up to a tube. The flyback won't energize, you don't got to worry about getting shocked. So we have our connections for our meter to read our voltage. All we got to do is turn it on. Touch this to the frame for the ground, touch this to center for power, and it should light up. And we're hoping to see around, if I recall, somewhere around 130 volts. I got a 75 watt power supply. I'm sorry, 75 watt light bulb. I was using a 20 watt light bulb, and this was usually around 138 or so. But I think with a 75 watt light bulb, it may be more of a load on the circuit. We're looking for B+ to be around 117. Now I don't know what it's going to read with a 75 watt light bulb because I don't know what type of load. This is the first time I'm using a 75 watt. Usually I use around 20 watt. But either way, we're just checking to make sure the light bulb lights up. We'll worry about B+ later. Alright, so here we go. 1, 2, 3. Oh, it's ticking right now. We don't have, usually goes to 180 volts. We've got something wrong in our power supply. You can hear it. I was going to take you off the overhead and you can hear it, but if I just raise this up here, well, maybe not. Here, I'll just take you off the overhead. Listen. Tick, 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 tick. So, I think we have a power supply problem. That would explain why the HOT is good. Well, tests good. That's very interesting. This is the first time I've encountered something like this, because I guarantee you, if I touch, we have 27 volts instead of 180 or so. I guarantee you, if I touch this to here and touch our light bulb, nothing. Nothing. We have a faulty power supply. And I'll bet you dollars to donuts, it's the U101, our switch mode power supply chip. And we can take some readings on that, and I'll bet you dollars to donuts, it's the U101. And because this should absolutely not be ticking with the B plus removed from the rest of the chassis. Only thing that's powered is this power supply. So if it's going tick, 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 then obviously there's something wrong with the power supply. And I'll bet you it's got to be that U101. Very interesting, because this should be around 180 or so volts DC with a functioning power supply with no load on the circuit by having that inductor out. So immediately I knew something was wrong by not having our 180 volts. And again, if we touch our ground and touch this, nothing. And that's because we don't have anything for our power supply. All right, well, let's turn this off. And because we don't have it hooked up on a tube, there's no bleeder. So what we're going to do is just tap this to ground here, and that should bleed off our voltage. There you go, 0. Okay. It still says 17, but yeah, we'll just leave this on here for a minute. All right, let's measure based off of previous experience. It's been so long since I've measured the U101 that I'm probably going to be pretty rusty, but I can tell you, I'll be able to tell you immediately if something is not right. How am I going to do this here? Okay. So I think from here to here, voltage drop, we should also get the same thing from here to here. Well, I don't know if it's not, there's an internal diode inside this IC, and it's not exactly the same reading, but there you go. See, you should have a diode across these two pins, and a diode across these two pins, and I think it's supposed to be 1.0 and 1.9 on this one. What does that say? 1.5, okay, and 1.9, yeah, so I thought it was 1.0, 1.9, so that actually reads relatively correctly. As I look at this, though, we've got what looks like a cracked joint here on our flyback. However, the flyback is out of the circuit. When L100 is removed, this flyback isn't even part of the circuit. But I'll reflow that real quick. And then this one here also appears to be in bad shape. If I can get this, you can kind of see the crack around that one. It's hard to tell. Yeah, so let's hit up that one too. Might as well hit that. I know you want to hit that. I know you want to hit that, hit that. Huh. Well, let's start checking other components in the power supply section, because that U101 actually didn't read all that out of range, out of tolerance. Let's just check some other stuff here, just for the sake of it. Let's leave it on diode checker, and let's check our rectifier diodes, which I'm assuming are okay because our fuse isn't blown. Yeah, they're fine. Okay, let's test. What are these diodes in here? This is, I can't see because there's no light. D108. That one's okay. I'll grab this one here. That one's alright. Let's go to resistance. Oh, you know what? I'll bet you our voltage regulator is bad. I haven't seen a bad voltage regulator and I can't tell you how long. Wait a minute, what's this? 450 meg? 450, oh, 4.2, okay. That doesn't seem right. Let's test our voltage regulator. This guy right here is our voltage regulator. Let's test that. I wonder if that's any good. I haven't had a power supply section failure in quite a while. So this is kind of refreshing here. Okay, negative lead on the center and positive to each. I think it's 0.5 voltage drop to one leg and I think it's 1 point something to the other. So, yep, 1.0 and 0.5 voltage drop. Well, voltage regulator, I don't think that's the problem. Huh. Like I say, they're pretty robust. I don't recall really ever having one go bad in recent memory, but I have had them go bad. Let's take a look here. I'm tempted to just shotgun in a new U101. I've got some in stock here. I shouldn't be reflowing stuff in case it's a bad solder joint on something, but I don't think so. Well, is that test point? Yeah, that's supposed to be that way, okay. Yeah, let's test some of these other diodes here though. Good, 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 good. Why are those resistors reading in the megohm? That's the curiosity. Those diodes are all okay. Okay. $700 ohms. Yes, more like it. 50K, 700K, 30. Yeah, those are fine. Huh. Well, yeah, let's put a new switch mode power supply chip in there and see what that does, because without being able to regulate anything, I think that the chip has to be the problem. So let's get this out of here. You know what? Let me turn on the desoldering station just to make it easier on all of us. And in the meantime, I'll search through the stash here and grab some of those. RGB chip and bada bing. I've got what looks like quite a lot. They never just easily fall out of there. Unless you don't want them to fall out, then they fall out easily. Where did my tweezers go? Here they are. Got it. Brand new. And what these are UC3842 Alpha November. UC3842 Alpha November. Okay. I'm going to set this aside in case we replace the chip and it doesn't fix it. we can put the original chip back in the stock here. 'Cause I'm not gonna take the new chip out, put the old chip back in. If it's not the chip, I can just leave the new one in there. I thought for sure that those resistors were initially reading in the mega ohm, that we had a bad voltage regulator, but with the fact that after they cooled down, they started reading correctly. So give me a moment here for this to heat up a little bit, and we'll get this changed out. Okay, so let's untangle this mess I have over here. All right. Okay. Man, it's hard to, I'm using the soldering iron because of the large plane here. It's easier to get these holes opened up on the larger planes when you have extra heat from the iron, because it's a bigger surface area. It's a bigger surface area than just the ring around the tip of this well, this tool here. There we go, just fell right out. Just that easy. All right. Here's our old one. We'll set that aside. Here is our new one. And we'll bend the legs in slightly. Alright, make sure we put it in there in the correct orientation. The keyway goes towards the flyback, so we're going to put it in here like... I may have to use the old tweezers here. We'll put this in like so. Bam, right in there. Okay. Let's get it soldered in. Let's get it soldered. Let's get it soldered in here. Sorry, I had to. And let's keep flowing and flowing. Oh, I messed that up. Flow in and flow in. That's hard to do. Flow in and flow in and flow in and flow in. Ah, come on, you rat bastard. Ugh. Like a bridge over troubled solder, I will flux you down. Alright, let's make sure we didn't create any bridges. I don't want to take a trip to Madison County today. Any bridges that I didn't obviously see like just now, but okay, good there, good there, good there. We are good there, and good there. And in comparison, let's read this and see what if it's any different. I think we had 0.51 something here. That's a bit higher. And then 0.6 on this one. Yeah, same thing. 1.5, I think. It's a bit higher. 1.9. Yeah, 1.8. But okay, well, if we do our light bulb test now and it's still, you know what, we don't even need to worry about hooking anything up. Let's just turn it on and see if it's ticking. If it's not ticking, then we have a success. So let's turn off the desoldering station and the fan here so we can hear what's going on. And okay, here we go. Are we going to hear it ticking? 1, 2, 3. Nope, it's not ticking. Let's hook up our, let's go back out here. Let's hook up our ground. And ground. Power. Power! More power! And let's grab that on there. Okay, and let's try this again here. Let's go volts DC, and we're hoping to see around 180. 2 points, yep. All right, here we go. What are we gonna get? 1, 2, 3. Oh, crap. Now it's ticking again, but at a much quicker pace. Very interesting, very interesting. We don't have a bad transformer, do we? I've never encountered that before, ever. Okay, so we know it's not the chip. When I first turned it on, it wasn't going tick 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 like it was before. It wasn't making any noise, I don't think. But after leaving it on for a little bit longer, I could hear it ticking, but it was a much faster paced tick. Here, let me turn it back on. You can hear it. I'll turn it on. Now listen to it. Yeah. Don't want to leave it run too long, but we're only at 20 to 28 volts. So something is still wrong. It's not the switch mode power supply chip. I mean, and I was skeptical with the fact that it read okay, or read somewhat normally, the original one, but I thought for sure that had to have been it because the voltage regulator tested good, R104 was good. Wow, this is going to be a head scratcher. I don't like head scratchers. They give me a bellyache, and I got a beauty right now. Sorry, old Star Trek reference for you. Well, let's test C106 because I've seen that be bad before. C106 is this film capacitor here. And all these film capacitors, we're just checking to make sure that they're not shorted. There's not really any way to know without removing them from the circuit and using a tester that I don't have to know if they're good or not. But, well, nothing. And I don't think that's open. It's 9.6K. Well, I'm a bit mystified here, boys and girls. Do we have a bad Q703? Because that'll cause problems, but usually a bad Q703, you'll just have a completely dead chassis. You won't hear it ticking, it'll be nothing if Q703 is faulty. But let's check Q703. That's, again, this guy here with the heatsink on it. And we'll just go, I think it's, instead of middle leg to each outer, I think this one is outer leg to center and left leg. Yeah, 0.7. Let's flip the leads around here. Open and 0.6. I think that's a normal reading, if I recall. let's grab this 7500 and verify on it. We'll read it the same way, and nothing in the middle. Outer leg was what, 0.7? Yep, and flip it around. Middle leg is nothing, outer leg 0.6. Yeah, so Q703 is good. And like I say, it'll usually be good, or you can usually tell it's good, because if it's bad, it'll be totally dead. It won't tick, it just won't do anything. Huh. Plus, I think it's out of the circuit. I think it's even out of the circuit when this is out, the coil. Just kind of grasping at straws here. There's got to be, I've had it before where one of these two capacitors here was bad. It had a broken leg, but that had a bunch of corrosion in here. Corrosion had got underneath there and it had eaten away the leg of this capacitor, and that kept the chip from functioning. But I don't think that's the case here, because this board is pretty pristine. But stranger things have happened. Is this diode any good here? Yeah. Huh. Well, I'm tempted to just do some poking around, seeing if I can find anything, and then kind of coming back, because, you know, in the interest of not having an hour-and-a-half long video like some of these tend to be, I'll see if I can find something, and when and if I do, I'll just come right back and say, here's the problem. You know, I don't really like doing that, but sometimes that's really all I can do. It may be a bad transformer. I've just never seen that happen before. I wonder if we could do some poking around here and just see, let's see, 0, 0. But see, that's off of the output of the coil. 0.2, I mean, that's dead short. 0.1. And the input, I think, is here. 0.2. 0.1. You know what? I've got a parts 7500 here. Nope. 7400, 2574. I got part 74. Let's see what we get on this one. Well, okay, 0.2, that was odd. 0.1, 0.2. 0.2. $25 meg across there. I'm sure they'll eventually be open. It's going down though. 22 meg. This one is open. Open, open. Well, I don't think that's the issue. That's the input. This resistor here is 475 ohms. This one yeah, so it's not that resistor. We already checked the diode. The voltage regulator we already checked as well. 0.5 and 1.3. 0.5 and 1.0, but yeah, that's normal. Well, it's a very limited area. We know it's not the chip. It could be either one of these two caps. Let me change the caps in the power supply section here. This one, these two, and this one, these two, this one, and this one. I'm sorry, this one, these two, this one, and this one. Let me change those caps out and come right back and we'll see if that does anything. Okay, I made a discovery I think that may solve this problem. I changed out all the caps in the power supply section, all 5, this one, this one, this one, that one, and this one back here, and it didn't fix anything. It didn't make any difference. I still only had 25 volts on the B+ circuit. So I replaced the transformer here that I thought might have been the culprit. I swapped it out from this donor 7400. It made no difference, still only had 25 volts. At that point I started, you know, kind of grasping at straws, thinking, okay, nothing's testing bad, but it's not working. So I started pushing on various components. I pushed here, pushed the heatsink, pushed the caps, and then for shits and grins, I grabbed the flyback and kind of tweaked it. When I tweaked it, boom, I got my 180 volts. So there's a cold solder joint either on the flyback or somewhere around it, and I think I found it. But let me give you some show and tell here. So if we turn this on here, 1, 2, oh, nope, I gotta plug it back in, sorry. Okay. Okay, so here we go. 1, 2, 3. 25 volts. Now, watch what happens when I kind of tweak the flyback here. 190, 193, 194, 195. And now there's our voltage. Now, what's interesting though, is if I clip on our lead here and I touch our light bulb, it will momentarily light up and then go down to 50 volts. So we're making progress, but if I turn this off and I discharge it, oh, just like that, and then go back to our meter and turn it back on, yep, 25 volts. Tweak the flyback, 190. So we'll turn it back off and we'll discharge it. It doesn't like that. It's ticking like crazy. We may have a problem with the bleeder resistor. We may have a bad flyback. Anyway, alright, so let me show you what I think is the problem. Is I reflowed some of these solder joints on the flyback, but because I thought the flyback wasn't part of the power circuit, and it really isn't per se, but this one leg is. If we look here, we've got this leg right here. You can see it's slightly cracked around here. Right there. Can I get closer? Yeah. If we look at the right angle, you can see really right here. Maybe you can. That overhead light is troublesome sometimes. Right there, it's cracked. Now, if we follow that trace, it goes from here across a jumper, and then it goes to this circuit with this trace here, which if we follow it, goes around this way, up across this capacitor, across C121, and then right over to our power supply section off the transformer. So this leg is a transformer here. If you follow it through, it goes across this way, down, through, over this way, right to that post, right to that leg of the flyback, across this jumper to right. Sorry, here's the jumper, goes right to there. So the flyback is in circuit on the power supply section off of that trace. So if we were to reflow this, just like so. Now let's test it again. I mean, the flyback, for all intents and purposes, is not energized and not part of the circuit when you have this coil removed. But it turns out that I'm learning right here along with you guys that it is in play, at least a little bit, in the circuit for the power supply section off that leg. So, yep, we reflowed it. Now let's see if we get our voltage like we're supposed to. Alright, so let's clip that back on there. Let's clip this on here. And this on here. And hopefully we'll get our 180 volts immediately. 117, that's odd. Well, weird. Alright, let's plug this in. And here we go. Do we get our voltage? 1, 2, 3. Something's not right. How come? We're hooked up to the ground. Yep. Nope, still got, nope. That was not, even though that trace does go to the flyback, that was not our problem. Because as you can see, it's dwindling back down. If I move this and hold it, there we go. There's our voltage. On the unregulated B+, well actually I think it's regulated, but it's no, there's no load on it. If I let go of it, it starts ticking. So if I hold on it, it doesn't tick. The ticking has stopped. And it is climbing up. If I let go of it, now it's ticking and the voltage goes back down. Maybe you can hear it. Not sure if the camera's picking that up. But if I push on this, the ticking immediately stops and the voltage rises. So let's turn this off. There's still a faulty solder joint somewhere. Great. Well, at least we're making progress. Let's discharge this. Pop! It's alive! Okay, now we can safely work on it. Set all this aside and let's go a-gazing here and see if we can find where this faulty solder joint lies. You know what, let me zoom out and I'll go look in here, and if I find anything suspicious, I already did this though. If I see anything suspicious, so tweaking on this flexes the board in this area. I mean, I don't see anything. There's nothing obviously cracked. Yeah, nothing. I don't see any broken traces, any cuts, any gouges, any damage, any cracked joints. Nothing here anyway. We've reflowed those 4 pads on the flyback. That wasn't the cause. Yeah, I'm not seeing it. I mean, it could be the heatsink, but the heatsink is just a heatsink. There's no reason why this would cause it, but it doesn't. I mean, it's not soldered in very well, but I'm not seeing anything. We obviously have a bad solder joint. That's absolutely apparent. But where is it and what is it? Well, I think what I'm going to do is I'm just going to go through here and reflow every single solder joint from here this way. This entire thing, I'm just going to reflow everything. And then we'll see. So let me get that done and I'll come right back. Okay, so I have successfully reflowed every single solder joint from here over on the entire chassis. Or on the entire section, I should say. So that's got to be it. Let's see here. Let's grab our, we still got our positive hooked up here. Let's hook up our negative. Negative, Ghost Rider, the pattern is full. Oh, we still got 26 volts sitting on there. That's odd. I thought I discharged it last time. Well, alright, let's plug our power in. And we're hoping for 180 volts. Think we're ready? Here we go. 1, 2, 3. No. It's still ticking. And oh, bam, 190 volts and no ticking. Yeah, you can hear it now. Ticking, no ticking. Ticking, no ticking. Well, it could be a bad B plus pot. If the B plus pot is bad, that could account for it. So let's change the B plus pot. Maybe that's the problem. Can I cut the glue off of it and turn it without breaking it? Not very likely. Ah, I did. Ha ha! Success, you sumbitch! Let's move the B plus pot back and forth a bunch of times. Let's see if that does anything. Okay, 1, 2, 3. Hey! We may be in business. Does our light bulb check work? Well, look at that! Let's zoom out a bit. Boom! Bad B plus pot. You've got to be kidding me. 146. That, yikes, that's way too high. Which way? I'll turn this a little bit to the left here. He says, there, let's see what that does. All this time, bad B plus pot? I should have thought of that. Oh, I didn't even think about that until just now. Gosh darn it. Still works. Okay. What do we have now? 144. So, yeah, I'm going to have to replace that B plus pot and get that turned down because that's our problem. Can I cut some more of this off to be able to move this more? Yes. Oh, wrong way. Wrong way. Strong if I can, but I am only a man. 137. That may be more appropriate. $134. See, without having a complete load on the circuit, I'm not sure what it would need to be. We can test this one and see what it reads. May even just swap it with that one, but I want to get closer to 117 if I can. 130, yeah. Let's just see with a meter. Let's discharge this. Okay. And let's just see what it reads on the other one. Oh, man, all this effort. Bad B plus pot. It does happen. Not the first time, won't be the last time, but usually they're fairly robust. Alright, so let's grab this one and just see what it reads as it's sitting here. Okay. Make sure we read this correctly. here to here. This is the same trace, so it doesn't do any good to read from there to there. Sitting here, we've got 456 ohms. So if we read our problem chassis, we've got 461. Pretty close there. All right. Well, I think given how close that is, I may tweak this just ever so slightly, a little bit. There we go. Let's see if we can reach 456 now. Close enough, 461. All right. All right, we are back in business, ladies and gentlemen. So let's put it completely back together, get it on a tube, see if it works, see what it looks like. Then, if it works, we can finish the full reflow, finish the rest of the caps, and do our neckboard work and everything we normally do to these that I do in every video, and then we can call this a success. Okay, so let's get it back together, get it on a tube, and see what we get. Alright, so we got our chassis back on the original picture tube that came with it from the factory. This is a matching set, and like I say, it came out of a 2-player NFL Blitz. And we are all hooked back up. Anode, neck, yoke, ground, power, video, remote. We have the test pattern generator here. I've already turned it on in anticipation of this working. And I'm sure the B+ pot's actually fine. I'm not going to change it out because we were able to successfully wipe it back and forth, clean off the contacts, and set it properly to what it should be, relatively speaking, compared to the donor chassis. So I don't think it's actually bad. I just sat in one location or one spot for so long that the connections developed oxidation and had to be wiped back and forth, and that kind of cleaned it up, and it's set to a new spot now, and I think we're probably going to be okay. So I got L100 back in, and we're ready to test. I have not tested this yet. I have not turned it on since hooking it up, so we can share in the knowledge whether or not it works now and what it looks like. And as I say this, I realize that I forgot to hook up the meter for B+. So I'm going to have to grab one of my, did I do red? Yeah, let's do red. Grab one of my leads here and hook up our B+. There's a dedicated test point, but I just clip on L100 right there. You can clip on L100 right there, and I believe the test point for B+ is actually right here. Can I get a shot of it there? Yeah, TP202B+, it's right here by this capacitor. But I just clip on L100 right there. Okay, volts DC. And it's going to be fun trying to do this one-handed here. Let's put that down and clip this on here. Right like that. Okay. And then let's get a black one. And clip that onto here. And clip this onto here. Alright, here we go. Does it work? Is it going to turn on? And will we be close to 117? Let's find out. 1, 2, 3. Outstanding. There you go. We're upside down. I got the yoke hooked up and upside down. Well, how about that? Bad B+ pot. Who would have thought? Move that over. Let's do width. Oh, that's as wide as it gets. Interesting. We got, I don't know, almost ½ inch and almost ½ inch. Interesting. Height. Height's good. Actually, not really. Vertical position. Let's bring that up. Now we can do height. Okay, that's good. Well, yeah, width is not wide enough, but I'm sure it's because of caps. So, yeah, there you go. It works. Let's make sure I can focus it. It's slightly out of focus. Let's make sure our focus actually works. Can I sneak in here? There we go. Okay. Oh, yeah. Nice. Look at that. Beautimous. Okay. Well, there we go. So, yeah, bad B+ pot. All that work, all that troubleshooting, all that effort led us to a faulty B+ pot.
well, it's not faulty. It was just it needed to be broken loose and wiped back and forth and set properly. Now we're at 118, which is pretty damn close to 117. But as the screen changes, see if I change the image, I'll press the button to go through the different options and watch what happens here. See, with this, it's 117.4. So we're perfect on the B+. Awesome. Okay, let's make sure we have RGB. Yep, I think we're on the road to success here. So the neck board actually doesn't really need a lot of work. I'll do the reflow and the recap and clean it up. But as you can see, it's not really burned up at all. It's in relatively good shape. Everything's aligned. I don't think none of the heat sinks are loose. Even the resistors are in good shape. They're not all touching each other and inducing heat on each other. So this should clean up very nicely. I'll do the cap kit, the rest of the cap kit, the full reflow, the rest of the reflow, the neck board rework, and we'll show this off at the end, and we'll make sure our B+ is still good, and that should seal this up. So yeah, quite the head scratcher there for a little bit, but we'll get all the rest of the work done. We'll come back and see how it looks and how it turns out. All right, all the work is done. Full complete reflow and rebuild on the neck, mainboard, cap kit, all inspected. Everything is now ready to go. We're all hooked back up and should be ready to go. Now I do want to preemptively set our sub-contrast pot, wipe it back and forth and put it to halfway, and then I want to take our neck board pots and wipe them back and forth and set them about 25%, because as I've said many times, these chassis don't like to be any higher than about 25% or the colors begin to bleed on you. So we'll do that. And then we will also preemptively set the brightness and contrast all the way down so we can properly set our flyback. Brightness all the way down, contrast all the way down. Okay. And I also reinstalled these wires here on the bottom side to accommodate how this was hooked up inside of the cabinet. I can't condone this, but that's just how it is. I'll have to make sure these don't touch each other while we're doing our testing. So, okay, now that we are ready to go, let's get this back on the tube and see how it turns out. All right, so here we go. We've got our meter hooked back up so we can measure our B+ to make sure it's still 117 or close to it. And then we have anode, neck, yoke, ground, power, video, remote. This time we're going to be using a Mortal Kombat Pcb so we can make sure we have all of the colors set properly. It's the easiest way I can, obviously you'd go through here and do your color bars and set your colors that way, but because I'm so familiar with what MK1 should look like on a working good tube, that I'm going to set the colors based off of MK1 here. So let's make sure it turns on and still works here after the reflow and the cap kit and the rework. Make sure there's no issues, make sure our B+ is still 117, then we'll set our colors and screen size, position, and whatnot, and we'll see how it turns out here. So 1, 2, 3. Hot damn. All right. Nothing has popped or smoking or is exploded. We're at 118.3, but like I say, this fluctuates based off what's on the screen. And we need to adjust our vertical hold right here. And we are backwards and upside down. Weren't we upside down last time? I don't know. I switched the horizontal. It looks like we were upside down and backwards, so I need to turn this off. So I switched the horizontal, but I didn't switch the vertical. So let's turn the vertical around. See what that does. And now we're backwards. So let's turn that off. I think we were originally backwards and I mistook it for being upside down. So let's flip our horizontal here. Okay, now we should be good. Yep, now we're good. So brightness and contrast is all the way down right now. And we can clearly see the background is not black. So we'll have to turn the flyback down until our background is black, which should be right there. And so there's our properly set flyback, and assuming it doesn't drift, that's where it needs to be set. And we can adjust our brightness to roughly reset. That's why this board's a test board, because it resets on me. But right there's our brightness and contrast. Nice. Look at that. H position. And it looks like we still don't have... We have width control. You piece of junk. We have width control, but it doesn't go all the way out. You can see the edge of the raster right there. So, yeah, but otherwise, that's awesome. Vertical position needs to go up. Let's decrease our height. And, yeah, that looks pretty darn good. And like I say, all of our contrast, our subcontrast is in the nominal position at 50%. These are at 25%, right where they like to be. And that looks pretty damn good just from initial testing, initial settings. Yeah, wow. It's a bit too red. And I'm not really worried about screen position and stuff and whatnot, but yeah. That looks pretty good. Right off the bat, crazy. Wow. Well, I'm going to say those colors are pretty darn good. I'm going to turn red down slightly. That's good. Man, I can't believe that looks that good just from the pre-settings. I don't have to adjust anything. That's awesome. That's perfect. Yes, wow, okay. I need to move vertical position down. I said I wasn't worried about it, but let's get it where it needs to be for MK. And we do have width. Look at that. Or all the way to the edge on this side and all the way to the edge on this side. We do. It was just the test pattern generator. That's why I like to use an actual PCB, ladies and gentlemen. Test pattern generator is great for what it is, but yes, look at that. All the way to the edge and all the way to the edge, and we have a full, complete picture, and it looks fantastic. And we're at 117 volts. Absolutely awesome. So, long story long here, we had a bad, well, we didn't have a bad B plus pot, but the B plus pot was in a position where it was oxidized. After wiping it back and forth, breaking it loose, wiping it back and forth, it came back to life, got everything rebuilt, reflowed and normal work, and readjusted, and got B plus set properly. And see, now it's 117.0. You can't get much better than that. So thanks a lot for watching. Hopefully you learned something. Like, share, and subscribe. I appreciate it. Leave comments down below what you think, and we'll see you on the next repair.